This next tangent graph, we have a pi over 3 inside. So we don't have a c this time. The c value would be a 0 on this problem. Okay, so the period is going to be, again, it's always pi over b. So it's going to be pi over 3. And we can flip and multiply that. The pi's are going to cancel out, and we get a 3 for the period. Next, we want to find the phase shift. The phase shift would be the opposite sign of c over b. Now, in this case, there is no c. It's 0. So for this one, the phase shift is going to be 0. We don't have a plus or minus. And whenever you have something like that, well, there's no plus or minus after the x, that means your phase shift is going to be a 0. Your HP, that's your half point. That's your period divided by 2. The period here is 3. So we're going to put 3 over 2 as the half point. So now here's how we're going to do the graph. There's no phase shift this time. So when I draw this, the 0 line is actually where the graph is going to be centered around. So this is 0 here. Remember that there is a dotted line here and here to get you one period. The way the drawing is, if you look back at that original tangent graph, the tangent graph had a 0 here, and it had this at negative pi over 2 and positive pi over 2. Well, this time, the period changed on us because we got this in the middle, and we found that our half point is going to be 3 halves. So what we're going to do here is we're going to take 0 minus 3 halves, first of all, to get negative 3 halves right here. And then to get the other one, we're going to do 0 plus 3 halves is going to get us this one right here. So 3 halves. There's no pi on that, just 3 halves. So that's going to give us one period of this. Now we want to find the other period. Okay, so we have to find the next point here and this one. For these, we're just going to keep adding 3 halves to it. So for the next one, I can just do 3 halves plus 3 halves, and so that equals 6 halves. Now I don't need to worry about reducing these. I'll just go ahead and leave it as 6 halves. If I add another 3 halves to that, this is going to give us 9 halves. So you just keep adding the half point all the way across to get all these here. All right, now the question is, what do we do about that 4? We haven't talked about this yet. We haven't done a problem with the 4. So here's how we're going to do that. I'll go ahead and I'll mark 4 on here. The way it happens with the tangent graphs is that the halfway point between the dotted line and this line right here, the graph is going to either be at negative 4 or at 4. Since the graph we know follows this general shape like that, okay, at the halfway point right between here, and we don't have to worry about labeling these. I only require you to label the x-intercepts and the vertical asymptotes only. But just for graphing purposes, at this point here, the graph is going to cross at negative 4. At this halfway point, the graph is going to be at 4. So what that 4 is doing is it's stretching the graph. It's a vertical stretch. So the graph is going to kind of come down like this, go in like that, and then kind of keep on going up. So it's actually stretched out a lot. And the same thing happens here. Between 3 halves and 6 halves, the graph's going to be down here at negative 4. Between 6 halves and 9 halves, the graph is going to be up here at 4. So that is what the vertical stretch does. So as you can see, it's elongating it, and it's kind of making it look more straight instead of the curve that we had for the previous problem there and the other tangent graphs we've looked at. So it ends up being kind of more stretched out like this, but that's what the 4 would actually do. It causes the graph to be in these two places here, and that's basically what that does and how it shows up on the graph.